Hi, welcome to my video. Now, in this video, what I'm going to do is I'm going to solve the problems based on this topic called non-homogeneous second-order differential equations. Now, the method that we're going to use is called the undetermined coefficients. Okay, so this is what took place. Okay, we have already learned about the first-order differential equations, and we have learned on how to solve those type of equations using different techniques. Now, in this case, when we talk about the non-homogeneous second-order differential equations, what are we talking about? Actually, there are two types of, in this case, there are two types of second-order differential equations. It could be non-homogeneous or it could be homogeneous, okay? But now, what is a second-order differential equation? For example, when we have a d squared y over dx squared plus b dy over dx plus c is equals to, let's say the function over here, it's g of x. This type of equation, it is called the second order differential equation. Now, whether to determine this second order differential equation, it is homogeneous or it is non-homogeneous, we look at what we call the forced function. The forced function in this case is a function that we see on this side of the equation, which is on the right-hand side of the equation. When the forced function, it is actually equals to 0, what type of second order differential equation are we talking about? We are talking about the homogeneous second order differential equation. But when our forced function may never be equals to 0, therefore, if our forced function may never be equals to 0, we are looking at whereby g of x is equals to constant, where g of x is equals to polynomial, where g of x is equals to a linear function, g of x is equals to exponential function, g of x is equals to trig or trigonometric function, where g of x is equals to sum of all functions. For example, maybe could be linear plus exponential or whatever the case could be, or it could be product, of different functions. So when g of x may never be equal to 0, but it is equals to one of these functions that I have just mentioned over here. Therefore, we are talking about the non-homogeneous second order differential equation. Okay, so in this concept, I am not gonna focus on homogeneous equations, but rather I am going to focus on non-homogeneous equations in this video. Okay, where our first function is one of the two, or one of the mentioned below. Now, what are we actually going to do in this concept? We are actually going to take the differential equation and we're going to determine the general solution. And we know that from the general solution, given that we have the conditions, we will be able to determine the particular solution. So basically, this is what it is going to take place in this video. Okay, so I'm not going to dwell too much on the basics because I really want to solve the questions as much as I can.